Well, now we're doing the review for section 7.4, and that's the area of a triangle, and the formula we're using can be found on page 564, and it's K equals S times the difference of S and A, S and B, S and C, where A, B, and C are the lengths of the sides of the triangle, and S equals half the sum of those lengths. So S equals 1/2 times 8 plus 6 plus 5, which equals 19 over 2. Okay, so K equals, applying that formula, the square root of 19 over 2 times 19 over 2 minus 8 times 19 over 2 minus 6 times 19 over 2 minus 5. And when we get a common denominator, for each difference, that common denominator is 2. So we have 19 minus double 8, you get 16 over 2. 19 double 6, you get 12, and all over 2. And double 5, and you get 10, and that's all over 2. Now, note, we have 4 factors of 2, and 2 to the 4th is 16, and the square root of 16 is 4, so we can factor out from that radical a 1/4. And now we're done with denominators, and so we have 19 times, and the difference in these two is 3. The difference in 19 and 12 is 7. And the difference in 19 and 10 is 9. Now, turns out one of these factors, 9, is a perfect square, and the square root of 9 is 3, so we have 3/4 times the square root of 19 times 3 times 7 is 21. So make note of that. We're going to erase this because we're out of room. Got that? Okay. So now K equals the square 3/4 times the square root, and when we multiply 19 and 21 together, we get 399. And running that through a calculator, we get a close approximation, which is 14.98 square units, whatever, square units, whatever they happen to be. They didn't give us units, so there we are. Well, now we're doing question 2 on the review for section 7.4. And here's the formula we're using. K equals 1/2 the product of the two sides of a triangle times the sine of the included angle. So K in this case equals 1/2 and times 3 times 2, 3 and 2, times the sine of 110 degrees. And here the 2's divide out, so we get K equals 3 times the sine of 110 degrees. And when I run that through the calculator, I get an approximate area of 2.82 square units. And we've done number 2. Well, now we're doing question 3 on the review for section 7.4. And we have to find the area of the segment of a circle whose radius is 8 feet and formed by a central angle of 70 degrees. Well, the area of the segment is this region in here that's shaded. So, what we have to do, we have to find the area of the sector, the piece of pie, so to speak, and then from that subtract the area of the triangle that's formed, and that difference will give us the area of this sector. So the area of the triangle, or the sector, I'm sorry, this is a segment. The area of the sector equals CTOR equals, and the ratio is 70 degrees over a total of 360 degrees times pi r squared. Well, if you square it, you get 64, so we have 64 pi. And when I carry out that product, I get approximately 39.1 units. Now, let's find the area of the triangle, and that's going to be 1/2 times 8 times 8, which is 64, and sine of 70 degrees. So that's times 64. And when I carry out that product, another irrational number, I get this approximation, 30.07. So then the area for the segment equals the difference of these two areas, and that is 9.03 square units, and we've done it.